This video is about star clusters and how they can be used to test ideas of stellar evolution. So, in a star cluster, like the one shown in this image, what you have is you have a whole bunch of stars that all formed about the same time with about the same composition from the same cloud of gas and dust. The only variable is mass. So, some of the stars ended up more massive, some less massive. And the other thing that's nice about them is that they're all the same distance away. And so if you look and see that one star is brighter than another, then it really is brighter. It's not just closer. Obviously, some are going to be on the near side of the cluster and some on the far side. So there is that variable. And there's always the possibility that there's a few stars that are between the Earth and that cluster. And those are known as foreground stars. And there could be stars behind it that we're seeing, and those are background stars. So there's a few little things that might make a difference here. But mostly, they're pretty good for testing these ideas of stellar evolution. And one of the ways that we do that is by looking at all the stars in a cluster and making an HR diagram of them. So here we have the HR diagram of a young cluster of stars, only 3 million years old. And this one, you can see that the stars that are up here on the main sequence have actually made it to the main sequence, whereas the lower stars here are still protostars and have not yet made it onto the main sequence. So they all start out over here somewhere, and then they kind of move over, and as they turn on, they get onto the main sequence here. So this one is very young, and all of the stars are either on the main sequence or about to get onto the main sequence. And there are some that are like this, including this one here, the Christmas tree cluster, which kind of does remind you of a Christmas tree, I guess. I mean, there is this part of it down here that kind of looks like the shape of a Christmas tree. Or maybe if you look at the whole thing and kind of flip it upside down, maybe that's what the Christmas tree is. I don't know. Anyway, this is what the uh, HR diagram of that type of thing would look like. Now, um, here's another one that's a young cluster, and you can see that they're more or less right on the main sequence or getting close to the main sequence. So this is a young one. This is actual data. The previous one was, this is actually just a simulation, but this one is the actual data for that cluster. And so you can see this part of it, the heavier stars, the more massive stars are on the main sequence. These are going to get there soon. So here we've got an open cluster that has evolved for a while. So what happens is that the stars that are farther up on the main sequence, which are the heavier stars, the brighter stars, the bluer stars, are going to evolve off the main sequence faster. And so as the cluster ages, the stars kind of peel off the main sequence. And you can see the turnoff point for them is just right about in here. And so the farther down the main sequence that turnoff point is, the older it is, the older the cluster is. And so what you see over here are some red giants. So these are the redder looking ones here. These are ones that were more massive stars. They're actually still massive and have evolved off the main sequence and are currently in that red giant phase, which all stars eventually go to. These stars are less massive and are still in the main sequence. They are still in the hydrogen burning phase of their life. But as the cluster gets older, more and more of these will evolve off the main sequence, and you'll see this turnoff point go down further. Here's an example of one that's a little bit older. This is a little over 4 billion years old, 4,240 million years old. And this again is a simulation, and you can see the turnoff point here. And this are some of the red giants up in this area. Now here's a globular cluster, and it turns out that globular clusters are all pretty old. And you can see that this is stars that are still on the main sequence here. and then there's a really pronounced turn-off point here, and then you've got red giants up and down here, and then this is the kind of horizontal branch here, and these are some pretty bright stars. They're kind of back to burning, but helium in this case. And so they're in this kind of temporary stability phase here. But eventually, these will all end up as white dwarfs way down in the lower left. Now, the other thing to note about this diagram is that we're focused way in on the lower part of the main sequence. So we've kind of clipped off the rest of the main sequence where it would be up here. This only goes up to a luminosity of 100 L suns. So we're way down there. So this is a really old one. And that's what you need to know about star clusters and how they age and what their HR diagrams look like.